Welcome back again to this part of the session of the numerical problems that I will be going to solve related to the street of phelps equation. In the last previous class, we have derived and obtained the equations and the solutions related to the street of phelps equation, whereas in the utmost care, the solutions has given what will be the deficit of the DO in the case of the disposal of the effluents on either to the river or maybe to the streams and all. So, in the practical manner, how does it takes place? We can be able to understand the problem as well as how to analyze the problem in order to yield the solution in a differential manner. So, how it is? Let us get to know when we solve the problems related to that. So, take down the problem. A stream having flow of 1 meter cube per second, a stream having flow of 1 meter cube per second and BOD 4 mg per liter and BOD 4 mg per liter is saturated with DO, full stop. It receives an effluent discharge of 0.25 meter cube per second having BOD 20 mg per liter and DO 4 mg per liter, full stop. If the average velocity of flow is 0.15 meter per second, calculate the DO deficit at the points 20 kilometer and 40 kilometer downstream and 40 kilometer downstream. Assume that the temperature is 20 degrees Celsius. Throughout the BOD is measured at 5 days, full stop. Take rate constant for effluent and stream as 0.12 and 0.30 per day respectively, and saturation DO at 20 degrees centigrade is as 9.17 mg per liter. So, let us get to know the solution to this problem. Okay, solution to the street of phelps numerical problem. Now, what are the given data? First, let us get to analyze the problem, okay, apply the concepts, and then the relative part, it is related to the rivers or maybe the streams. So, what they have given, a stream having a flow of 1 meter cube per second and BOD 4 mg per liter, and it is saturated with the DO, it is asking. So, here you need to check that stream having the flow, that is Q of the stream having the flow, what is that given as 1 meter cube per second, and then what else given? BOD is 4 mg per liter, that is Ys is equal to, that is or Y5 S is equal to 4 mg per liter. Next, saturated with the DO. What is given? Saturation, it is 9.17. It is given as saturated with the DO. DO is equal to, that is C is equal to 9.17 mg per liter. Okay, then what else? Receives an effluent discharge of 0.25 meter cube per second. When there is a receiving of the effluent discharge, the discharge of the effluent, it is denoted as what? It is denoted as QE. The discharge of an effluent QE is equal to how much it is given as 0.25 meter cube per second. 0.25 meter cube per second. Next, what else they are asking here? 0.25 meter cube per second, having the BOD concentration of 20 mg per liter. So Wi-Fi is equal to 20 mg per liter. And what about the DO, that is C is equal to, given as 4 mg per liter. C is given as 4 mg per liter. Next, if the average velocity of flow is 0.15 meter cube per second, which is the velocity of the flow here, that you need to determine. The velocity of the flow, which is given as U is equal to 0.15 meter per second. This is the average. Because of the computation of those two, I will yield the average velocity. Calculate the DO deficit at the points 20 and 40 kilometers. You need to determine D deficit at 20 kilometer and deficit at 40 kilometers. These are the type 1 problems that you need to remember, where we apply the case of the mass balance equation for the dilution factor, assuming that the complete mixing position, and later onwards we need to solve by using the solution obtained from the street of Phelps equation. Instead of an exponential, it can also be determined through the power of the 10. Okay. Now here, what else that we need to take it out? Assume that, what are the assumptions given? Temperature T is 20 degree throughout the BOD measured in 5 days. That is, T is constant. So T is equal to 20 degree Celsius. Okay. That is no changes in the temperature. And BOD measured is 5 days. Take the rate constant for the effluent and the stream is given. So what is that? Effluent rate constant is given as KD, that is equal to 0.12 per day, as well as Ka is given, how much it is? 0.3 per day. 0.3 per day. Okay, this is how you should able to analyze the problem in this manner. Then it becomes an easier part of the task how to solve the problem. They are asking at the downstream distances. Okay, after certain conditions and all, there is a disposal. I'll show in the cut section itself only. Distance at like a 20 kilometer as well as the 40 kilometer stretch. How much it is? I'll choose it here also. What is the DO? I want to get to know here. Now, in order to get to know, I need to get to know what is the average concentration of the BOD as well as the DO also. That is obtained by the mass balance equation. Step 1, determine the average DO as well as the BOD concentration. Step 1, determine the average DO and BOD concentration. What is that? Wi-Fi mix and C mix. That is the DO as well as the this is for the DO and this is for the BOD. Please do remember, I am choosing like this. Let us get to know what is the formula for the Y mix at the downstream. Before you need to compute it, whatever the mixture that is taking place, Y mix is given as stream, concentration of the stream, that is YS, plus effluent and the concentration of that divided by Qs plus Qe. That is equal to Qs is how much? It is 1 meter cube per second. Say 1 into what is the Ys? That is 4 mg per liter of the BOD concentration plus Qe is 0.25 into what is the Ye is equal to? It is given as 20 divided by what is Qs plus Qa. It is yielding to 1.25 because 1 plus 0.25. How much? It has to be expressed in terms of an mg per liter. You are going to get it as a Y mix. So when you compute it, 4 ones are 4 here, 25 twos it is 50, leading to the answer as 5 plus 4 9, 9 divided by 1.25. So the BOD is 7.2 mg per liter. Now we have determined what is the value of the BOD. Next is C mix. To determine the C mix, that is a DO mix, that is given as Qs into Cs plus Qe into Ce divided by Qs plus Qe, where you have what is the discharge is 1 into what is the concentration of the DO, it is 9.17 plus what is the concentration here, 0.25. So 0.25 into what it is, the C is given as 4 and then 1 plus 0.25. Okay, now we shall compute it. How much it is? So 9.17 plus 0.25 into 4 gives you nothing but the 1, 10.17 divided by 1.25 gives you 8.13. That is the DO mix. That is the DO concentration is C mix is equal to 8.13 mg per liter. Now if I know what is the DO as well as the BOD, because Wi-Fi mix I got to know, what is the L0 I need to determine it, because here carefully you need to analyze the equation. What is the street of Phelps equation is given as? The deficit at any point is given as D is equal to D naught into e power minus Ka into T plus Kd L naught divided by Ka minus Kd into e raised to minus Kd into T minus e raised to minus Ka into T. So this is the exponential form of an expression. That means if I have given with the Kd as well as the Ka, all these things is given. I need to determine what is the time. Time they have not given, only the distance is given. At what distances, how much is the velocity that they are asking it. Okay, and meanwhile I don't know what is the value of the L0. Thereby I need to calculate what is the value of the L0 here. You can calculate here only, but for the references, what are the equation or the deficit that you need to know, you need to calculate this. Therefore, L0 is equal to Wi-Fi divided by 1 minus e raised to minus Kd into T, or else what you have, look at here at the constant. What are the constants that we have taken up? Either it can also be represented as Wi-Fi divided by 1 minus 10 raised to minus Kd into T. If you look at the constant is 0.12 per day and this is given as 0.3 per day, what happens? Obviously when it is given as 0.12, directly take it as 10 raised to. And if you wanted to have in terms of an exponential, multiply by the given multiplicable factors, thereby you are going to get it. That is 2.303. If you multiply it, you are going to take it in an exponential form. If you divide it by 2.303, that is nothing but multiply by 0.434. Like that you are going to get it. Next, that is equal to Wi-Fi is nothing but the Y mix, 7.2 divided by 1 minus 10 raised to minus what is the Kd value is 0.12, and I have to get to know what is the T value also here. T value is normally it is for the 5 days, because the BOD, the time given as an interval, that is T is equal to 5 days. Okay, now feeling easy here, and let us get to solve 7.2 divided by 1 minus 10 raised to 0.12. How much? Let us get to calculate it. 7.2 divided by 1 minus 10 raised to minus 0.12 into 5. So, you are going to get it as 9.615 mg per liters. Okay. So, when we have got all these things and all, next thing it is, I need to determine what is the D naught value. Okay. I need to find out what is the D naught value also. Let me rub this apart. So, D naught is equal to Cs minus what is the C, we will take it as. Okay. So, saturation concentration is given as how much it is? 9.17. That is Cs minus C is nothing but the C mix. C mix is given as how much it is? 8.13. Thereby, I am going to get what is the initial deficit here. So, 9.17 minus 8.13, 1.04. So, D naught is equal to 1.04 mg per liters. Now, we have find out what are the required data. The next step is to determine the deficit. In order to determine the deficit, I need to know what is the time. So, in order to find out the deficit at 20 degree, next step 2, to find the deficit. To find the deficit at 20 kilometer, what is given, that is you need to determine what is the T value. So, T is nothing but x by u, where x is the distance given as 20 kilometer, as well as what is the u is equal to, convert this 20 kilometers in terms of a meter. So, 20 into 10 raised to 3 meters, and u is equal to 0.15 meter, u is equal to 0.15 meter per second, and here T is to be taken in terms of in days, to be converted in terms of in days means how much it is to be converted in terms of in 24 into the, what about the seconds has to be converted into minutes, and minutes to hours. Therefore, you are going to yield what is the time in terms of in days. Now, let us get to compute here. T is equal to 20,000 divided by 0.15 into 24 into 3600. Let us get to know what is the time is 1.543 days. 1.543 days. Now, determine the deficit. When you get to know, you need to determine the deficit here. What is that? So, D, observe it here, D is equal to D naught into e power minus k into t plus kd L naught divided by Ka minus Kd 10 raised to minus Kd into T 10 raised to minus K into T, which supposed to be a D at 20, that is equal to D naught is 1.04 into 10 raised to minus 0.3 into what is the time interval is given as, here time is equal to 1.543 into Kd L naught. What is that? Kd is equal to 0.12 into what is the L naught value is, let me take it as 9.62 divided by 0.3 minus 0.12, that is the one thing. Next, here it is plus and multiply this multiplicable factor, it is given as 10 raised to minus Kd is 0.12 into what is the T value is 1.543 minus 10 raised to minus Ka is 0.3 into 1.543. That is equal to how much it is. So, D20 is equal to, you need to determine it in terms of an mg per liter, you get it as 2.34 mg per liter. So, this is how you are going to get the value. The deficit at 20 kilometer is found to be 2.34 mg per liter. Now, next step is step 3 to determine deficit D at 40 kilometer stretch. Deficit at 40 kilometer stretch means initial deficit remains the same, but only changes related to the time which is required, and that will tend to change it over here, the intervals of the time. How much is the initial deficit that likely to takes place here? Okay, let us get to know what is the solution for it. So, T is equal to x by u. What is that? X is equal to 40 into 10 raised to 3 meter, and what is the u is equal to? U is 0.15 into 24 hours 60 minutes as well as 60 seconds. Okay, this is in terms of in meter per second, in terms of in days. How much you are going to get it? 3.086 days. 3.086 days. Now again apply the same equation, that is D at 40, that is equal to D naught into 10 raised to minus KD into T plus KD L naught divided by KA minus KD into 10 raised to minus of 0. That is afterwards let us take it as KD into T minus 10 raised to minus Ka into T. Okay, understanding it. Now let us get to compute it. So D at 40 is equal to D naught is how much? 1.04 into 10 raised to minus KD value is 0.12 into 3.086 plus KD value, it is, this part remains the same, no any other sort of changes. 0.12 into 9.62 divided by what is the Ka minus Kd? 0.3 minus 0.12 into 10 raised to minus what is the value of the Kd? It is again here 0.12 into 3.086 minus 10 raised to minus 0.3 into 3.086. This is how carefully you need to analyze. Now break apart, you compute the value of this individually and then you can add it up. That would be an easier task. Otherwise the things becomes much more complicated for you to solve this equation. Now let us get to know what is the D naught value. 1.04 into 10 raised to minus 0. Sorry, this is 0.3 here, 0.3. This is Ka, so the value is 2.07 mg per liter. Okay, so what about the DO at this stage is 2.34, and here at the downstream it is 2.17, which implies that what? The DO, when you have considered here, initially that mix after this, the initial stages was how much it is related to that at the stretch, that is at the initial deficit was 1.04 mg per liter. Then what happened at the stretch of the 20 kilometers, that means the water that is need to travel, it requires in the case of after 1.543 days interval, the deficit becomes of the DO concentration is 2.34, and after 40 kilometer it has decreased. That means what is the trend final overall solution if you take it 20 as well as the 40, the DO is decreasing like this. This is the DO and this is with respect to the flow in time, or in terms of in kilometers if you are going to take it, that is for the 20 as well as for the 40, how it is changing. This is how you are going to get the solution. Okay, clear with this kind of the problems related to this? Okay. If any other set of the problems is there, kindly you can able to make the solutions pertaining to it. Okay. This is how we need to solve the problem related to the Streeter-Phelps equation. Any doubts that you have related to this, you can ask. Wastewater is being discharged. Wastewater is to be discharged at a rate of 75 million liters per day into a river with KD is equal to, or whatever. See, in the case of the problems, whether if they go for giving it as in terms of an R or maybe a Ka or K2 or like K1 and all, that you need to identify clearly. Always the reoxygenation coefficient or reaeration coefficient will be greater than deoxygenation coefficient. Please do remember the term. Okay, with R is equal to 0.25 per day, that is nothing but Ka itself only, at 20 degrees Celsius. During the low water period, the flow rate in the river is 10 meter cube per second. The flow rate in the river is 10 meter cube per second at a temperature of 24 degree centigrade. 24 degrees centigrade. Determine the maximum allowable 5-day BOD. Determine the maximum allowable 5-day BOD of the wastewater at 20 degrees Celsius. If the dissolved oxygen content below the outfall is to be not less than 4 mg per liter, full stop. Assume that the wastewater temperature is 24 degrees Celsius and that of the river water above the outfall is 95% saturated with oxygen. 95% saturated with oxygen. From the laboratory test, the value of K was found to be, from the laboratory test, the value of K was found to be equal to 0.12 per day, 0.12 per day at 24 degrees Celsius. Saturation dissolved oxygen concentration for river water at 24 degrees Celsius is 8.53 mg per liter. 8.53 mg per liter. Analogy that you need to make it here. A river is flowing and the wastewater is discharged into the river. Okay, it is flowing on. So this is the case. So what and all the things given here? Given wastewater is to be discharged at a rate of 75 million liters per day. That is given as in terms of a day 75 into 10 raised to 6 liters per day, that is equal to wastewater to be discharged. Next, again what it is given with river with R is equal to 0.25 per day, where the river concentration having the Ka or that is equal to R, or maybe it is like K2 minus K1 or anything that you are going to take it, it is always 0.25 per day. Next, at 20 degrees Celsius, that is for the condition that is temperature is equal to 20 degrees Celsius. During the low water period, the flow rate of the river is 10 meter cube per second at a temperature. The flow of the river water, that is QR, is equal to 10 meter cube per second. And how much is the temperature? T is equal to 24 degree Celsius. Here it is 20 degree. That is the reaeration coefficient. This is at the how much? This is for that temperature T is equal to 20 degree. K is 0.25 per day. And what about the river water condition? It is 24 degrees. There is a change in the temperature, apply the temperature correction factors. Next, what else is given? During the low water period, the flow rate of the river is 10 meter cube per second at a temperature 24 degrees. Determine the maximum allowable BOD of the wastewater at 20 degree centigrade, that is maximum allowable BOD concentration, that we need to find it out. Okay. So, what is the maximum allowable 5-day BOD of the wastewater? That is, I need to determine Wi-Fi is equal to how much? Wi-Fi, I don't know, I need to evaluate it. Next, if the dissolved oxygen content below the outfall is not less than 4 mg per liter, what it is given here, the dissolved oxygen content below the outfall is not less than 4 mg per liter, assume it is given that you need to find out the deficit content, and later on what is the critical oxygen deficit, you need to find it out. Assume the water temperature is 24 and that of the river is 95% saturated with the oxygen. Given the saturation oxygen concentration, that is CS is equal to 8.53, the dissolved oxygen concentration of the river is given as 95%, that is 0.95 of the CS. And then what else they have given? K value is given, that is the KD value. KD is equal to 0.12 per day, 0.12 per day here. And next, what else is given? If the dissolved oxygen below the outfall should not be less than 4 mg per liter, the C, this should not be, that means less than 4 mg per liter means C concentration is 4 mg per liter. What is the thing to find out is Wi-Fi, that you need to find it out. Now, let us get to know the equation here. Let us solve it. Given the dissolved oxygen content of the river waters, I need to find what is the CR is equal to 0.95 times of SCS. So, let us find the solution. Before finding out the solution, whatever the data has to be in a proper manner, that you need to set it. Then only it becomes a fruitful manner. 0.95 times of SCS is 0.95 into what is the value of the CS is here? It is 8.53 mg per liter. 8.53 mg per liter. How much you going to get it? So 0.95 into 8.53, 8.10 mg per liter. That is the concentration of the DO of the river. Find out. Okay, fine. What is the, I need to find out what is the C should be. Okay, it should be here, but this is not the CE. And now I need to determine what is the C mix here, because if I know the C mix, then I can be easily, if I know the C mix, I can easily calculate what is the initial deficit, that I need to take it up. And what about the time period? Time period here it is not given. Therefore, you need to calculate the deficit in terms of a critical deficit, that is DC and as well as the TC, critical time, at what time the deficit occurs. And here the CE value is found to be 0. It is not given means 0 it is. Now determine C mix and then temperature, KD, correction factor to be applied. Okay, sorry, Ka you need to determine it, and then D naught also. You need to determine all those things. Let us determine this. So C mix is given as, C mix is equal to, you need to convert this 7.75, that is how much it is, 75 million liters per of water. So before determining this, you need to have a Q. So QE is 75 into 10 raised to 6 liters per day. that has to be 75 into 10 raised to 6 divided by what else it is given here. You need to convert in terms of a meter cube per second, thereby 24 into 60 into 60 into 10 raised to 3. How much? That has to be expressed in terms of a meter cube per second. Okay. Now, let us compute it. 75 into 10 raised to 6, and this will get cancelled. Only 3 is remaining. So, 75,000. What about the river? It is 10 meter cube per second. So, Q is equal to QR plus QE. That is how much it is? 10 plus 0.868, that is equal to 10.868 meter cube per second will be the flow at the downstream conditions. Okay. Now, what else to be determined? I need to determine what is the C mix. Let us find out. So, C mix is equal to QRCR plus QECE divided by QR plus QE. So, what is the QR is equal to 10 meter cube per second into what is the CR is equal to how much we have got 8.10 mg per liter, 8.10 mg per liter. What is the value of the QE is equal to 0.868, CE value is 0, therefore this whole term becomes 0 and 10.868. So, 10 into 8.1 divided by 10.868, how much you are going to get it? So, 10 into 8.10 into 81 divided by 10.868, 7.45 mg per liter. That will be the DO mix concentration. What is the D naught is equal to deficit is equal to CS minus C mix. CS is 8.53 minus C mix is equal to 7.45. How much you determine in terms of an mg per liter. This gives you the initial deficit, how much it is happening at the point of the discharge. So, 8.53 minus 7.45, that is equal to 1.08 mg per liter. Okay, fine. We have computed this D naught and C mix. What about the Ka? Given Ka at how much it is given as 20. The temperature correction factor is Ka of T is equal to Ka of that is that 24, no, I need to find out that Ka at 20 into 1.016 whole raised to the power of T minus 20. What is that Ka at 20 given as 0.25. So, 0.25 into 1.016 whole raised to the power of 24 minus 20. How much it is? Let us get to compute it. 1.016 whole raised to the power of 4 into 0.25. 0.26 you are going to get it. 0.266. That is Ka at 24 per day. It is expressed. Here, the question they have not asked find the deficit. That means you need to get to know how does the deficit tends to takes place. That means they are asking the DC as well as the TC also. Let us get to know how to find out the DC value. Normally the deficit at the point, because here you need to see that maximum allowable first stage BOD concentration they are asking it. So, what is the maximum allowable BOD concentration? They are telling it as here important thing BOD they have not asked, but it is present. How to determine it? We need to make use of the formulas by using the trial and error method. Here assume or sometimes what happens, the KD value or maybe the BOD value will be given, but you need to find it out. Assume the value to be 20 mg per liter, because if I need to find out what is the ultimate BOD, that is KD L naught, I have to determine it. L naught value has to be taken up here. Without that, it is not feasible also. L naught, that is ultimate BOD remaining here. I don't know how to determine the BOD concentration here also, they have not given it. Okay, in the both cases the BOD has not given. Let us assume for a while maximum what is the allowable concentration, it is ranging from 20 to 30. Okay, so at the just below the outfall it has to be maximum at how much it is. BOD has to be like a 20 or 30, that is a range. Keeping that as a standard, because based upon the standard, the ultimate BOD to be how much it is 20, and afterwards the BOD that you can able to determine it. Now let us take it here. What is the DC is equal to KD by KA L naught into 10 raised to minus KD into T. I need to determine what is the TC value is equal to. TC is equal to what? 1 divided by KA minus KD into logarithm to the base 10 of, because we are using the natural log, logarithm to base 10, logarithm of Ka by Kd into 1 minus d naught into Ka minus Kd divided by Kd into L naught. I need to determine what is the Tc. Now D naught I have got to know, L naught I have kept here, I have maximum based upon that. Okay, let us get to determine, because BOD value we don't know. If I know what is the BOD value, then we can able to get it. That is the equation that not naturally it represented. Now, so here let us assume it as 18 mg per liter. Here what happens, DC I have formula KD L naught divided by Ka, and here KD into TC. TC is given as 1 divided by Ka minus Kd logarithm to base 10 of Ka by Kd into 1 minus d naught into Ka minus Kd by Kd L naught. Here what I will do here, let me take it as 18 mg per liter. How, on what basis that you have taken as 18 mg per liter? Why not 20 or 24 like that? Because see here, what they are asking is the deficit that takes place, that is the D minimum is equal to how much? It should be 4. So 4 is equal to what is the CS concentration is? CS is how much it is? 8.53, okay, 8.53 minus C mix. That is D minimum CS minus. So I wanted to know what is the C mix concentration. C mix concentration is to be given as how much it is? It has to be 4, okay. And totally it is 8.53 if you are going to take it minus 4, how much you are going to get it as? It is 4.53 D min is equal to, if the allowable part of it. Based upon that, you need to have a certain changes with the trial and error conditions. This is using this. Otherwise we have another next set of the problem where you need to estimate the self purification constant. So Tc is given observed here. Upon solving this, you are going to get it as Tc as how much it is? 2.145 days. 2.145 days. Next, DC is equal to Kd is 0.12 divided by Ka is 0.266 into L naught is equal to 18 into 10 raised to minus Kd is equal to 0.12 into Tc is equal to 2.145. Let us get to know what is the value of the DC. So DC is equal to expressed in terms of an mg per liter. How much it is? Let us get to know, compute it or evaluate it. The DC, that is 0.12 into 18 divided by 0.266 into 10 raised to minus 0.12 into 2.145. It gives you 4.489. 4.489. Observe it here. Okay, now DC deficit is given. So DC is equal to how much it is? I know. So I need to know what is the allowable concentration, that is C is equal to Cs minus Dc. Therefore, C minimum is equal to how much it is getting it, and it should always be greater than 4 mg per liter, and that you need to think it. Okay. Now Cs is how much it is? 8.53 minus 4.48. How much you are going to get it? 8.53 minus 4.48. So minus 8.53. So 4.04 you are going to get it. 4.04 mg per liter. That is the deficit that is taking place. Now what else that you need to take it out here? The remark that you need to write it, the first stage BOD concentration, here the first stage BOD concentration should not be more than 18 mg per liter, should not be more than 18 mg per liter in order to maintain the minimum dissolved oxygen concentration at the outfall that is to be required. Okay, this is required. Hence the statement has to be written it here. Now I can able to determine what is the Wi-Fi now with this. Now let me determine it here itself only. So with this here, let me determine what is the maximum allowable 5-day BOD. Determine maximum allowable 5-day BOD. Determine maximum allowable 5-day BOD. 5-day BOD. What happens here? We know that Wi-Fi is equal to L0 into 1 minus 10 raised to minus KD into T. The KD is always given at 20 degrees centigrade. Now here KD is equal to 0.12 per day. That too it is given in terms of an what? Here changes takes place. KD at 24 it is given as 0.12. So KD at 24 is equal to 0.12. I need to get it now what is KD at 20 degrees centigrade is equal to how much? That is K of T is equal to KD at 2 1.047 whole raised to the power of T minus 20. I need to get this. What is the KT value I have? That is KT is equal to how much it is? 0.12. So 0.12 is equal to KD into 1.047 whole raised to the power of 24 minus 20, which implies that KD is equal to 0.12 divided by 1.047 whole raised to the power of 4, that you are going to get it. So can you tell me the answer? That is equal to 0.12 divided by 10 raised to how much it is? Sorry, it is 1.047 whole raised to the power of how much it is given as 4. So 0.099 per day. Okay, KD I know. I need to calculate what is the here the BOD concentration. Let us get to know. So Wi-Fi is equal to KD, that is L0 into 1 minus e to the power of minus KD into T. L0 is 18 into 1 minus, sorry, this is in terms of 10 raised to minus, what is the value of the KD is equal to 0.099 into the T is 5 here. Okay. Now you are going to get in terms of an mg per liter, that is Wi-Fi, and after that you need to determine what is the C mix concentration for this, the maximum allowable concentration for the BOD. Now we have, that is 1 minus 10 raised to 0. That is minus 0.099 into 5. how much it is? 0.68 into 18 gives you 12.24 mg per liter. Now calculate what is the Wi-Fi mix. Wi-Fi mix. Assume that the BOD is, river is 0. Assume BOD of river to be 0. Now Wi-Fi mix we can able to calculate, that is the allowable concentration here. What happens here after this, assuming that Wi-Fi mix is equal to QR YR plus QE YE divided by QR plus QE. How much it is? Here this is 10 meter cube per second, this is 0.868 meter cube per second. Okay, now what happens here, it is 10.868 and the river is 0. 10 into 0 plus what is the QE is equal to 0.868 into what is the YE is equal to 12.24 mg per liter, which implies that Y mix is equal to how much you need to, therefore I need to get to know what is the YE value, that is YE is equal to how much, Wi-Fi E. Okay, Wi-Fi mix is nothing but this Y mix. So Y mix is equal to QR or YR plus QE YE divided by QR plus QE, that is equal to, what is the QR is equal to? QR is equal to 10 into YR is equal to 0 plus QE is equal to how much, it is 0.868 into YE. This value is 12.24, you are going to get it, divided by what is the formula here, QR plus Q is 10.868. When this is equal to 0, only thing is numerator by denominator, which will lead to give you the answer, that is YE is equal to, you multiply this 12.24 into 10.868 divided by how much it is, 0.868. So 12.24 into 10.868, 133.030 divided by 0.868 gives you 153.25 mg per liter should be the allowable maximum, should be the maximum allowable BOD of the effluent. So this is how you need to get the solution. Okay. So getting the solution, how you need to solve the problem, it is quite lengthy in nature, but you need to practice it well and finally you need to solve the problem related to this. Okay, otherwise it will be quietly difficult also to solve the problems related. Okay, with this, in the next part of the topic, let me take up the type 3 problems. Type 2, you have get to know how to solve with respect to the temperature correction factor when the BOD is not given. Type 3, there are again varieties, two varieties, namely with respect to the self-purification constant, you need to determine what is the deficit that is taking place. How and why it is taking place, let us get to know. Okay, still then stay tuned for it, and thank you one and all.